Good afternoon and welcome to this mini session on welding fumes. Welding is an extremely common practice in both construction and industry. Even if welding isn't necessary to manufacture a company's product, say the company manufactures frozen foods, welding is still likely performed from time to time to repair damaged equipment or modify existing equipment. If you're unfamiliar with welding, it's a process by which metal pieces are fused together. In the image on your screen, the welder is joining two pieces of metal together by introducing a consumable wire through the nozzle that is being held. Intense heat melts the consumable and the metal surfaces together, creating a pool of molten metal which solidifies. You now have a unified part where once there were two. What metals a welder is exposed to and in which proportions depends largely upon the composition of the base metal and the composition of the consumable. The question is, how do we know if a welder's exposure to metals is healthful or harmful? To answer this question, one must first understand a key concept: the dose makes the poison. Consider toothpaste. We all swallow some toothpaste, hopefully on a daily basis, and we're all fine. That's because a normal person would need to consume 33 tubes of toothpaste in order for the dose to be toxic. Also consider water. We all drink water, but we are aware that excessive consumption can be toxic. Again, what determines toxicity is the dose. Returning to our question, and now the answer, the first step to determining whether a welder's exposure is healthful or harmful is to quantify the welder's daily dose to metals. We measure dose by collecting air samples from the welder while he or she performs a typical day of work. Air samples are collected using equipment similar to what is shown on your screen. Laboratories then analyze the collected samples for a variety of metals and report back the concentrations or dose to each of the metal types. The next step is to compare the metal concentrations or doses against OSHA's legal limits for those metals. For example, you can see that the full shift limit for iron oxide is 10 milligrams per cubic meter of air. To be legally compliant, a welder's dose of iron oxide cannot exceed 10. Here's the newsflash. OSHA's limits are extremely outdated and in many instances are not protective enough based upon the most current science. For this reason, it's important to compare your results against the limits set by best practice groups, such as the ACGIH, or American Conference of Governmental Industrial Hygienists. Going back to our iron oxide example, the ACGIH has recommended that daily exposure to iron oxide not exceed 5. Let's practice applying these limits. Imagine that a welder's exposure to iron oxide is 7 milligrams per cubic meter of air. That exposure is legal because it's below OSHA's legal limit of 10. But it is not healthful as it exceeds the recommended limit of 5. It's important to recognize that while we perform these comparisons individually, one by one, metal by metal, most metals affect similar organ systems. This suggests that even if metals aren't present at harmful levels individually, they may be collectively harmful. Think about a bucket that you fill with stress. You introduce one minor stress to the bucket doesn't overflow. 2 minor stressors, you're still okay. But you add 10 stressors to that bucket in a day, that bucket overflows, and now you've got a full-blown stress event. The same can be said for contaminants. In and of themselves, they may not pose a threat, but collectively they can be harmful. In fact, welding fumes as a whole are carcinogenic. IARC, the International Agency for Research on Cancer, has classified welding fumes as Group 1 carcinogens. This means that there is enough evidence to conclude that welding fumes can cause cancer in humans. This provides additional credence to the need to assess not only doses to individual metals, but their collective impact. An industrial hygienist can easily do this by performing a calculation described in the standard 1910-1000. I hope that you're taking away from this presentation how important it is to measure your welder's daily dose to metals so that you can determine whether or not exposures are both legal and healthful. I also hope that you understand why welding fumes should be assessed holistically as they affect similar organ systems and are